Superimposed. Welcome to my channel, Learning Builds Life, and today we are going to talk about electron orbitals. Before we move on to electron orbitals, let's discuss about the concentric circle diagram, which was depicted in the previous few episodes. So, in the 1900s, it was believed that the concentric circle model, concentric circle diagram for an atom was thought that it was the actual way that atom used to be there. So in the 1900s, a concentric circle diagram for an atom was thought to be actual structure of an atom. So it was taught this, and still we use this concentric circle diagram for a few books to represent that, yes, the atom is actually like this. But some theories suggest that the concentric circle diagram is actually not the correct representation for an atom, because we don't know the position of the electrons. The electron positions are not fixed. Electron positions cannot be determined. They're not fixed. But we know that the electrons can be in some kind of space or area in which it is supposed to be there 90% of the time. That space or area is represented by different shapes and of different sizes called orbitals. These are in different shapes and sizes, and like for example, let's take actually the orbitals are dependent on the energy level. So like we discussed previously, the electrons had different levels of energy. So every electron level, energy level, represents a different, there is a different orbital for each energy level. Like for example, take neon. The first shell has 2 electrons, which is having the 1s shell, the 1s orbital. Then the second shell has 8 electrons, which is going to be occupied by 2s and 3 2p orbitals. Means 3 2p orbitals. And and 2p orbitals. One s, 2s, and 2p orbitals. 1s is for the first shell. Now I can draw the orbitals separately, and then I will draw the orbitals superimposed. That means how actually the orbital arrangement should be in case of the neon atom. Okay, firstly 1s, so that is one small circle, which is a space for the first shell electrons. Then we have, this is for the first shell. First shell. And now for the second shell, we have the 2s orbital and 3 2p orbitals, which can be drawn like a flower shape, but actually it's 3D. this is one orbital, this is one orbital, and this is another orbital. I know it's a little bit clumsy, but I'm again showing. These two, this is one orbital, this is one orbital, and this is one orbital. They are arranged in this format to show the three 2p orbitals, but this is actually in 3D format. And this is the 2s. This is for second shell. This whole arrangement is for a second shell. These were the orbitals represented separately. Now, 1 minute. And now if I represent the orbitals superimposed, it will look like a little bit clumsy, but we can understand, we can make out something from it. So first, we will draw this. Then we can draw the 2s orbital. We have already done the second shell, and superimposed, we do this 1s shell. So 1s, 2s, and the three 2p orbitals together, this is the orbital arrangement for neon. Ne. Now, there is something more about orbitals. Every orbital has a capacity of 2 electrons. Orbital capacity, sorry. Two electrons. Now, that is meaningful because if you see here, the first shell has 2 electrons, and the 2 electrons are in the 1s orbital. And now if we look in the second shell, we have the 2s, which is having 2 electrons, one of the 2p, which has 2 electrons, that means 4, then another 2p orbital, which has 2 electrons, 6, and another orbital, which has 2 electrons, 8. So 2 plus 8, 2 here, and 8 totally over here makes up 10 electrons, which is the electron configuration is satisfying neon. So the orbital capacity is 2 electrons. This is one of the most important points we have to remember. Let's revise a little bit. So we know that in the 1900s, the concentric circle diagram, that means this one, I'm just showing it to make it clear. This is the nucleus. This is the first shell. This is the second shell, and like that it continues, the number of shells, but this is the atomic nucleus. And these are our shells. Electron shells. These are electron shells, and this is the nucleus. This is how is the concentric circle diagram represented. For an atom was thought to be the actual structure of an atom, but that's not true. Since we don't know the electron positions, they are not fixed. They are in any space or area, which they should be in 90% of the time, and that area is represented by different shapes of different sizes called orbitals. Now here we saw the example of neon, where we have the 1s orbital, the 2s, and 3 2p orbitals, which are represented like this. And superimposed, this is separately for first shell and second shell, and this is the superimposed format of how actually the orbitals should be arranged in case of the structure of neon. And the orbital capacity is 2 electrons. Now you may take a look at the board. Hope you enjoyed this episode, and please like, share, and subscribe my channel, and stay tuned for more videos. Thank you.